Good morning, class. Today we're shifting into 5.2, the point twos, and today's title is How Can I Describe a Sequence? So first of all, that's a question. What is a sequence? Hopefully by the end of the day we'll know and we'll start to figure out how to write some rules for sequences. We're going to look at a bunch of them. So in the bouncing ball activity yesterday from lesson 5.1.2 and 5.1.3, you use tables and graphs to represent a discrete situation. Today you'll learn about a new way to represent a discrete pattern called a sequence. So I guess first of all, let's talk a little bit about yesterday and get into what we mean by discrete. So in yesterday's lesson, oops, let me go over here. I have some student work for this is actually a compilation of responses from two different students that I received. So if you recognize sentences or graphs from your work, it's kind of a collection of different things. So we did start with this a table. We were asked to create a table, and our rebound ratio was zero point 0.6. So if I have an initial height of 200 inches, after one bounce, it recovered and came back to 120, and then 72, and then 43.2. So each time I moved down this sequence, we were multiplying by zero point 0.6. I think the ball was recovering 60% or zero point 0.6 of its original height. The student said the independent variable in this situation is the number of bounces, independent, and the dependent variable is the height of the ball. This is because the height of the ball depends on how many times it's bounced, right? We have a graph of this situation off to the right here. It's a great graph. It's different. This student said this graph should be discrete, for if you look at the x-axis, it's representing the number of times the ball has bounced. These values can only be whole numbers, for each bounce counts as one. You cannot have a ball a half of a bounce. That's great. You got 2.3 bounces. So when the situation is discrete, we understand that the values in between these don't count, right? So I can have after the second bounce, it'll come to this height. Third bounce, this height. I can't have a 3.5 bounce. Doesn't happen. 31. Yesterday's graph, and that's not yesterday, but the day before that. Yesterday's graph, initial drop height versus rebound height. Okay, so yesterday's graph was the initial drop height versus the rebound height, and today's graph are different in two ways. Okay, so yesterday's graph, which was this one, and today's graph are two different in two different ways. Yesterday's graph had a positive slope, was increasing, and was linear. So you can see, although this little bump right here makes me think maybe it could be a curve, but I think if we had more data, um, this graph, especially compared to this one, right? This um, appears to be linear, and it is increasing. The higher the ball's initial height, the higher the rebound height was. Today's situation was nonlinear and decreasing. Okay, it is. This is not a line, and it is decreasing over time. Um, the ball only recovered about 60% of its heights each time. So that's what we were looking at before, and we can see when I say discrete, when we talk about discrete, it's like we can have one bounce, two bounce, three bounce, four bounce. So we're going to move into this idea of discrete as we talk about sequences. Samantha was thinking about George and Lenny and their rabbits. When she listed the number of rabbits George and Lenny could have at the end of each month, she ended up with the ordered list below called a sequence. So what is a sequence? It's an ordered list, right? These are in order, and we each of these have terms, right? This is the first term, this is the second term, this is the third term. This is not the zeroth term, right? So we begin with one. So it's the first time, the second time, the third time, the fourth time. She realized that she could represent the situation by using a sequence generating machine that would generate the number of rabbits each month by doing something to the previous month's number of rabbits. She tested her generator by putting the first term of 6, and she recorded each output before putting it into the next machine. Below is a diagram she used to explain her idea to her teammates. So 6 goes in, it produces an output of 18. 18 goes in again, it produces an output of 54. But this machine keeps doing the same thing, right? But the output from 1 becomes the input back in again. What does Samantha's sequence generator seem to be doing to each input? What are the next 2 terms of Samantha's sequence? And show how you got your answer. And then Samantha decided to use the same sequence generator, but this time with a first term of 4. So this is different. It says, what are the next 4 terms in this sequence? So this is the first item I want you to do. I want you to answer A, B, and C. And again, you can see what's happening with these numbers. This machine's doing something. Tell me what it's doing. What are the next 2 terms for this sequence? And then consider putting in a different starting value. And if you put in a different starting value, how does the sequence look different? So that's the first question we're doing today, question 41. And then we're going to spend the rest of this lesson on 42. In fact, this will go into a second day. But today I'll tell you about where you should stop. But let's start discussing this. So 42. Samantha and her teacher have been busy creating new sequence generators and the sequences they produce. Below are the sequences Samantha and her teacher created. So you can see there's, what is it, 10 of these? 10 of these, and they're labeled A through J. It says your teacher is going to give you a piece of paper. I'm not going to. I'm not going to give you strips. What I am going to do instead is give you this. Oops, not that. This. Here we go. This Google slideshow, right? And the sequences are here, and you can move these around and organize these in different ways, because the first thing you're asked to do with these is to organize the sequences into families of similar sequences. So I highly recommend that you think about the people that you sit near in the classroom, and that you share one of your Google slideshows with that group, and then work together on that in slides. And then once you're finished, of course, and I actually am not going to collect this today. We're going to collect this at the end of day 2, so we'll be collecting this on Monday. So remember who's sharing the master show, so that you can come back to it and continue working. Um, but So your first task is to organize these into families. Now that's going to be difficult to do because you're not exactly sure what they look like. So you can look for some patterns, and maybe if you look at them, you can think, oh, this sequence is generated by doing this thing. These are generated by doing these. So maybe you could initially come up with a couple quick groups and just separate those somehow. And in fact, in slides, if you wanted to separate them, maybe you could draw a line down the middle and say, okay, I've got this kind and this kind, and maybe give me a description about, how do these work? So you can give me, oh, these are sequences that you get by doing this. That's a terrible description, but you'll give me something better. And then just move these around and get them into a couple families. And actually, it could be more than 2 families. It could be 3 or more families. So don't be surprised if some of them don't quite fit where you want them to. But the next thing I want you to do is to slide into producing a visual that helps us see each one of these a little bit more clearly. So in slides, I think your first job as a team is to initially sort the strips into groups based on your first glance at the sequence. Remember that you can sort the sequence into more than 2 families, so it can be more than 2. You'll have a chance to revise your group sequences throughout this activity, so just sort them in a way that you think makes sense to start out with. Which seems to behave similarly? Record your groupings and what they have in common before proceeding. So I think that's the first thing. On that first slide, group them, and then give me a description of which, what does it say? Record your groupings and what they have in common. So what is it that those things, your groupings, have in common? So type that. If one exists, determine a sequence generator growth pattern for each sequence and write it on the strips. Don't write it on the strips, just in text. do a small text box next to each one and say this is a sequence generator. And remember, the generators can be different things. It could be for example, a generator could be you keep adding 5. So every single time you move forward, you add 5. Or a sequence like yesterday, you keep multiplying by zero point 0.6. So every single time the ball bounced, you multiply by zero point 0.6. Or you could be subtracting 3 each time. So just write down uh, what you think the generator is, if one exists. Um, do your sequence families still make sense? If so, what new information do you have about your sequence families? If not, reorganize the strips and explain how you decided to group them. Okay, then moving on. Um, the next thing we're going to do is we're going to make heavy use of this E tool, and I'll show you how in just a moment. But we're going to create for each one of our sequences a graph and a table. So your table should compare the term number n to the value of each term t of n. So that means that your sequence itself is a list of outputs of the relationship, and the inputs are a list of positive integers. So this is an important, in fact, they used an exclamation mark here. What are the inputs to the sequence? A list of positive integers. And actually, I think it should start with 1, right? We should talk to the first. Oh, it says this. The sequence always starts at n equals 1. So the first term in a sequence is always t of 1. Attach the table to the sequence strip it represents. We're not doing strips, so let me show you how we're going to do this. Let's jump over back into slides. So when you're in here, I'm going to go ahead and grab just one of the sequences, the first sequence, and I am not making any claim that these two groupings or there should be more groupings make any sense. I just am talking now about how you would investigate one of these. So for this one, I'm just going to go ahead and paste it in here. There we go. This is this. And it says use the E tool to create a graph and a table for each sequence. Copy and paste both a table and a graph for each sequence. So here's the sequence. So let's go ahead and grab something for it. I'm going to jump over to, here's the E tool. Good. And what's nice about the E tool is it's organized well. It has all of the sequences here. And they've even started the first one and I finished it. So if you look, the table, right, here's the n's and here's the t of n's. And if I hit this, you can see I've got a graph of these. So if I want to know, and it even says n and it says t of n, that's so super nice. So if I want to include these in my slide deck, I'm just going to go ahead and do a quick copy and paste. So I'll do, let's see, Shift S. There we go. So of course your OS is going to be a little bit different, but you can see I just copied that. And now I'm going to jump over into slides, to slides. Here it is. And I'm going to paste that, Control V. There. That's a beautiful table. Look at that. That's a table for this sequence. The first term is -4. The second term is -2. The third term, is -1. The third term is 2. The fourth term is 5. And then I take them all out to 7 like this. Okay, so now let's go get the graph. So I'm going to go back here to get the graph. I think I could do this easily by, yeah, share graph. I like to hit export image. There it is. It's beautiful. Make it a little bit thicker. And then I just typically will right click and say copy the image. So now that I've got my graph, I'll go back to slides and I'll paste that. So now I've got my table and my graph and the sequence written out like this. So we're going to be doing this for each one of these, and we're trying to look for how the sequences differ, how they're the same. In Desmos, I would not delete this to go on to the next one. What I would do instead is I would just turn off this particular sequence, right? And then I would look at the next one I'm going to do, which is 1.5, 3, 6, and then 12. And then just come down here and just do the quick Desmos. Okay, add a new table. Great. Now I would call these n, and I would call them t of n. Oh, that's going to be a problem because Desmos is like, you can't have that same name there. So maybe you are going to want to change these. I guess what's nice though is that the n values aren't going to change, because we're always going to be talking about the first term, the second term, the third term, the fourth term in the sequence. So what you could do is just come in and it was 1.5, 3, 6, and 12. So 1.5, 3, 6, 12. So if I look at this, well, actually, I don't want to talk about it. I want you guys to think about this, but I can clearly see. I think I see a pattern here. I think I see what's going on. And if I click this, I can look at and see what that looks like. Okay, so let's wrap this up then. What I'm looking for from your group today is an initial sorting of the sequences, a a list of the values in the sequence, a table of the sequence, and a graph of the sequence. I'm not asking for equations yet, so let's not go there. Just those three things. And if you need more of these, just copy and paste these, but they don't have anything special in them. They just have a place to put this stuff. All right, and we'll finish this section on Monday. But if you don't work on this sum today in your group, you're going to be at a huge disadvantage. So make sure that you do those things that we discussed today. This is Mr. Roberts. I'll see you in class and online soon. Have a great day.